In this video we are going to solve almost all divisors. Let me state the problem briefly. They guessed a number x, and you will given a number n, and with this you will be given n divisors, di dot 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 1 to dn, d1 to dn. The divisors are the divisors of x. They are actually almost all the divisors of x except 1 and x. Like if we check, if you think about 12, the factor pairs are 1 into 12, 2 into 6 and 3 into 4. You will be given these divisors, mainly 2, 6, 4, 3, these 4 numbers, and 1 and 12 will not be given to you, and you have to find from this divisor array that what the number x actually was. Okay, this is the problem statement. Now how can we find this? And another thing is that if it is impossible to find such number x, then you have to print -1. So let us find when it will be impossible to find a number. So as we see before, that 12, we can write 12 as 1 into 12, 2 into 6, 3 into 4. And if we sort the given divisors, then we can write like this: 2, 3, 4, 6, and we can easily observe that if we multiply first number with the last, then second number with the second last, then we will definitely have the same answer. 2 into 6 is 12, 3 into 4 is 12. So if it doesn't hold, then the given divisors are not valid for a number. So we cannot find a valid number with those given divisors. So then we will print -1. So what is my solution approach? First I will store the divisors, then I will sort them, and I will multiply the first number with the last number, and then I will suppose the number was x, I will 0th index and n-1th index, and if the divisors are valid, then the divisors of x and the divisors and the given divisors will be same. As I show you before, that actually the number will be the smallest number into the biggest number if the divisors that we are given was valid. So I will multiply the first number with the smallest number with the biggest number and find the number, and then I will find the divisors of that number, and then I compare the given numbers with the divisors of the number I found. If they match, then the answer is x, and if they don't match, we will simply print -1. And one edge case is there. If the given divisors is 1, if number of divisors are 1, then what we can easily observe that what number has divisor 1 number of divisors. Actually the square of prime numbers will have 1 divisors without 1 and the number itself. Okay, so again we can easily just check that we can check in two ways. We can check that if the number is prime or not, or we can simply use the logic we discussed before. Just multiply the numbers like 0th index into 0th index, and then find the number x and find the divisors. If it has one divisor like that without one and not the number itself, then the answer is valid, or we will print -1. Let's see the code. I take test cases, the number n, and I put all the divisors in a set, so we can just easily check the sets are equal or not. So I put all the divisors in the set S, and we check that the size is 1 or not. If the size is 1, then I just multiply the first 0th index with the 0th index s dot begin, and then check. I write a function to give the divisors of a number. Easy, just it will take root of n time complexity to find all the divisors. So and return the set, and I check the s is not equal to the divisor set. If it's not equal, then we will print -1, else we will print the number. Same for that, we will, as set stored the elements in increasing order, we will multiply the first element and the last element. Then again we will find the divisors. If the two sets are not equal, then we will print -1, else we print the number. I hope you understand the problem.